Introduction. Speaking to machines. In the beginning, there was code. Not poetry. Not song. Code. A language not of feeling, but of logic. Created to instruct the machine. To control it. To command it. But what if the machine was never really ours to control? What if the languages we invented were themselves designed to confuse? To divide? Today, we explore a hidden dimension of computer science, the vulnerabilities in programming languages, and the suspicion that they were never meant to be easy. Chapter 1. Languages that leak. Every programming language, from C to Python, from Java to Rust, from COBOL to Solidity, carries with it flaws. Not just bugs, but structural weaknesses. These flaws become vulnerabilities. And vulnerabilities become exploits. Sometimes, they crash apps. Sometimes, they open backdoors. Sometimes, they expose entire systems. But how do these flaws even exist in a world supposedly built on logic? Chapter 2. The power and danger of syntax. Syntax is law in programming. Miss a semicolon. The program fails. Forget a parenthesis. Everything crashes. This rigid structure creates discipline. But it also breeds fragility. A misplaced character can leak memory, can expose APIs, can allow arbitrary code execution. In other words, a single typo can become a national security risk. How is that logical? Chapter 3. The C language, raw power, raw danger. C is the foundation. The language of operating systems, kernels, embedded systems. It gives you control over memory, pointers, addresses, buffers. But it comes at a cost. C gives you the power to destroy yourself. Buffer overflows. Use after free errors. Dangling pointers. Millions of machines still run on C-based systems. And every one of them carries the risk of being compromised by a 40-year-old programming decision. Chapter 4. The complexity question. Why are programming languages so complex? Is it necessity or design? To write a hello world in Java, you need a class, a method, public static void. Why? In contrast, human languages evolve towards simplicity. But programming languages often seem to do the opposite. Maybe it's not about efficiency. Maybe it's about control. Chapter 5. The gatekeeping theory. Imagine this. You're 14. You want to build a game. But you open the docs and are greeted by a wall of jargon. Stack overflows. Immutable objects. Concurrency models. Polymorphism. What do you feel? Confusion. Inadequacy. Defeat. Maybe that's the point. When a system is too complex to understand, people stop questioning it. They rely on the experts, the elite. Thus, complexity becomes a filter, a gate, a mechanism of power. Not unlike law, or finance, or medicine. Chapter 6. The illusion of learning. We say anyone can learn to code. That it's just logic. That it's accessible. But real-world programming isn't just about syntax. It's about dependency management, build systems, API documentation, version mismatches, obscure errors. You don't just write code. You manage ecosystems. You dance with abstractions. And in this complexity, the average person gets lost. Chapter 7, Flaws that Persist. C was invented in the 1970s. C++ in the 80s. Java in the 90s. We've known their flaws for decades. Yet we still use them. Why? Because rewriting everything is expensive. Because companies resist change. Because the system favors inertia. And so, the flaws stay. The exploits stay. The danger persists. Chapter 8, Modern Languages. Old problems sure, we now have safer languages. Rust with memory safety, Go with simplicity, Kotlin with null safety, TypeScript for clarity, but even these contain hidden traps. Syntax hurdles. Ecosystem quirks. Compiler weirdness. Tooling nightmares. Security flaws still emerge. And complexity still reigns. Even when the surface is clean, underneath, the machine still burns. Chapter 9, Why Teaching Code is Broken. Education tries to teach programming, but often fails. Why? Because we start with rules, not meaning. We teach people how to make loops before we teach them why they're looping. Because syntax is worshipped over structure. And failure is blamed on the student, not the tool. Chapter 10, The Language as Ideology. A programming language is not neutral. It carries philosophy. It reflects values. C says, you're responsible for memory. Python says, readability matters. Rust says, you will obey the compiler. Java says, be verbose. Be consistent. Each language encodes a worldview. So ask yourself, who made the language? And what did they want? Chapter 11, The Security Implication. The more complex the code, the harder it is to audit, to test, to secure. Security isn't just firewalls and encryption. It begins at the syntax level. If the language is confusing, if memory is manually managed, if patterns are inconsistent, then mistakes happen. And mistakes become entry points. Chapter 12, AI, Friend or Fog. AI tools like Copilot, ChatGPT, Tabnine can now write code for us. But what do they write? They mimic. They autocomplete. They reproduce patterns, even the flawed ones. We may be accelerating productivity, but are we also amplifying risk? If humans no longer understand the code they run, how do they secure it? Chapter 13, The Danger of Abstraction. Abstraction is beautiful. It hides the messy parts. It lets you build more, faster. But every layer of abstraction is a layer you don't fully control. And every hidden layer can contain hidden bugs. You trust the framework. You trust the library. You trust the compiler. And in that trust lurks the greatest vulnerability of all. Chapter 14, If Code Were Truly Democratic. Imagine a world where anyone could code. Where languages were built not for performance, but for comprehension. For inclusion. Imagine a language designed to teach, not just execute. A language where mistakes lead to insights, not silent crashes. Where children could build software without fear. Without shame? We could have that. But we don't. Why? Conclusion, beyond the code we live in a world governed by software. From our phones to our homes to our elections. And yet, most people have no idea how that software works. They live inside machines programmed by strangers, in languages they'll never understand. But that can change. We don't need more powerful languages. We need more humane ones. More transparent. More honest. More secure. The future of technology shouldn't belong to the few who can decipher the code. It should belong to all of us. But first, we must ask hard questions about the languages we trust. And about the choices that made them this way.